Welcome to the last part of episode 2, How to Make Among Us in Unity. I'm Adrian and today we will dive into how to create the wire task. If you haven't seen the previous parts, a video should appear right now. Also, for convenience, I have created a playlist containing all the previous episodes and the ones that are gonna be released. Now, let's get into action. The wire task. Probably the most complex we have yet on this tutorial series, but it's not going to be a problem for us. This video is split up in different parts as follows. Firstly, we will look into how to set up the wire hierarchy. Then, we will head into the scripting and generate random colors for all the wire ends. Next, we will take a look at how to create the drag wire functionality. And lastly, we will head back to the wire task script to implement the win condition. And with that said, let's get right into it. As usual, we will create an empty game object and name it the wire task. I fast forwarded the elements setup since it's mostly positioning similar to the elements in the hierarchy. One thing to note here is that to quickly align the wire ends, we can use the vertical layout grip, which will automatically do that for us. For the right wire ends, we will need to copy paste the previous wires and move them to the other side. Don't forget to name them, otherwise it might get confusing. Now let's get into scripting. Before we dive into the wire color generation, which is located in the wire task script, we have to make a quick stop in the wire script. This is because we need to be able to see the wire colors to understand what we actually do. Basically, this functionality, it will be directly linked to the wire task. Here we just need to get the image component and create a function that when called can change that image color. Let's head over to the wire task script and implement the random color generation part. Firstly, it would be nice if we can specify which colors the wires can have. We will use a list for this. Then we will create two more lists, one for the left wires and one for the right wires. We will attach the wires into the inspector later on. The lists called available wires, available left wire index and available right wire index are needed for the random generation sequence. And before we discuss the code, it's probably better to also explain the process of picking random colors for the wires. We will use a list of colors, duplicated from the original. This is needed because this list will be manipulated. More exactly, we will start removing elements from it. Then we will pick a random number from the start of the list to the end of the list, and we will get the color situated at that position. And this will require that we initialize the color list with the actual colors. For the wires, if we create a simple for loop, we will have both ends on the same level without intersection. To pick random ends, we will use the same process as for the colors. We will make a count from 0 to the last element and we will initialize the wire index with 0, 1, 2 until the last element. Note here, it's not actually needed to randomize both ends, only one. For the purpose of this tutorial, I have chosen to randomize both. The most important part is the while loop, which ends until there is no more colors or wire ends to pick from. These lists will have their count decreased at each step. Here we select the random color and store it. We do the same thing for both indexes. Now we need to assign the actual wire ends from both and right part with the chosen color. This is where the function we implemented in the wire script comes in hand. Lastly, to not make this loop infinite, we need to remove the chosen color as well as the chosen index from each list. Let's see how that works. By the way, don't forget to attach the wire script to the wires and the wire task to the correct object. To initialize the wire lists, we will use the lock inspector situated top right and drag and drop the wires to their correct lists in the wire task. Now we can also pick the colors. Be careful here as the alpha is initially 0. Now for each multiple run we can see that the colors are correctly randomized. To create the wire drag functionality, we need to get the wire script up again. We will use a line renderer for this, also a reference to the canvas. We will initialize both in the awake, the first function called when the object gets created. In update, which happens every frame, we will compute the final move position by using rect transform utility screen point to local point in rectangle. This will transform our mouse pointer location into a location on the UI canvas. Now, we need to set up the line renderer. The first position is of course this wire's end, but the last one is the position we just computed. For the drag functionality to work in Unity, we need to implement the drag interfaces. You can right-click on each one of them and hit implement, and the functions will be generated automatically. Don't forget to either remove the exception or comment it, otherwise when a drag event will happen, you'll get errors. We will use only on begin drag on the end drag, though the other one is still necessary, so don't remove it. And since we do everything in the update function, here you just need to know if the object is dragged or not. We also need to create a material for the wire. This is important because it will render the wire above other UI elements. Next, we will add the line renderer to all the wires and customize it. The color does not matter because we will automatically assign it. What matters is the wire's width and the material which we just created. Let's quickly test it. It seems to work, but the wires get stuck. That's because we need to detect if the drag ended and clear the line renderer. Testing it again will show that it works properly. You might notice that the wire still gets rendered below other elements. We need to set the wire's material render queue to a bigger value. This will fix all the issues with the order of the rendering. Also, we don't want to be able to drag and drop the right end of the wire. For this, we will create a bool and set it in the inspector for the wires on the left side. And simply check before starting the drag to see if it's the left wire or not. To change the line renderer's color, we need to set that color in the setColor function. Now, for the last part, we need to work in both the wire script as well as the wire task script. We will start by getting the reference to the wire task in the wire. And since this is a parented to the wire, it's quite easy to obtain. In the wire task, we will need to have reference to the current dragged wire as well as the current hovered wire. Now, the wire needs to inform the wire task that this is the current one active, and also, when the drag stops, to inform back that it's not the active one anymore. Since I could not find the functionality that tells which object is hovered, I went ahead and implemented this on my own. I used isHovered variable, which based on the current mouse position determines if the cursor is above the wire or not. Note that the function is a little different than the one that used before. It's called rectangle contains screen point. Now we need to check when the drag ends if the wires match color. And here we also need somehow to access the wire's color. And if they match color, mark it as successful and be sure to, when the drag stops, to not clear the line but to keep it because it's correct. A good idea is to prevent dragging a wire that is connected correctly already. This is optional though. This last check is mostly for security. This should not happen because each color has only one end on each side. But of course there is a special case if you drag the wire on top of itself, so it still protects the code from that case. Now for the final part, to check if all the wires are connected successfully to complete the task. We don't need to check it every frame, so we can move the code to a coroutine to optimize the game a little. And this is the final result, and also the end of the episode 2. In the next episode you will see more multiplayer functionalities. If you want to get notified when the next episode is uploaded, don't forget to subscribe and turn the notifications on. I'm Adrian and I'm signing out.